join me in welcoming Dr. Moniz.
Well, thank you, Rich, especially for your biting your tongue at the appropriate place. But thanks to you and the Academy and for having me here for this Sackler lecture. Let me just first start with a little bit of a retrospective about DOE. Rich said that I served in the second Obama term as secretary, and I think a lot of people don't fully appreciate what the scope of DOE's activities are. What we like to summarize them as weapons and windmills, quarks and quagmires. The weapons is because DOE is the repository of nuclear security issues, nuclear weapons, nuclear proliferation. The windmills to symbolize, of course, the clean energy responsibilities of the department. Quarks because the department is the largest funder in the physical sciences in terms of basic research and facilities for our national scientific community, and quagmires because we inherited the mess of making those nuclear weapons during the Cold War. But in putting those four general mission areas out, all of which, by the way, I would emphasize, are brought together by their reliance on science and technology. DOE is fundamentally a science organization, and I see here a lot of the national lab people apparently have all come here. DOE operates 17, doesn't operate actually, we have others operate. DOE has 17 national laboratories. But in that set of missions, what I would emphasize is that two of them really are directly connected to major global, potentially existential threats. One, on nuclear weapons, hopefully low probability of use, but high and rather immediate consequences if used. And then climate change, which is quite different in terms of a slow motion train wreck that we seem by observation to be rather poorly equipped to handle politically. A classic tragedy of the commons. A quarter century ago, in the early 90s, there was considerable reason for optimism on both of these threats. On the nuclear weapons, the end of the Cold War really provided an opportunity, and many, in fact, I recommend your fellow Californian Bill Perry's former Secretary of Defense book, in which he notes that he was a Cold Warrior, came back into the Obama administration, prepared now to dismantle the nuclear enterprise, and has been disappointed that, in fact, that is not the direction that the world has been going. And then, similarly, in the early 90s, we tend to forget the meeting in Rio de Janeiro, the UN Framework Convention on Climate Change. It was adopted. This was a treaty ratified by the United States Senate. With the commitment to stabilize greenhouse gas concentrations at a level preventing dangerous anthropogenic interference in the climate system. Of course, it left open what that meant quantitatively, but I do think it's worth remembering that we actually have a treaty ratified by the Senate to pursue these goals. Instead, today, on the first of those threats, it's my judgment, at least, that the risk of nuclear weapon use, don't get me wrong, not a high probability, but higher than any time since the Cuban Missile Crisis, with the risk resting mainly in the dangers of miscalculation with new technologies like cyber threats and with the unstable political relationships that we have seen developing recently. On climate, we had that wonderful Rio event, but today we remain mired in a morass of science denial, informed that the standards we must meet are a lot tougher than we thought in 1992, and advancing solutions, and that'll be our discussion today, at too slow a pace to meet those tougher standards. President Obama put both of these issues forward as high priorities in his administration. In fact, I would say my job interview in December 2012 covered exactly those two and no other issues. And in April 2009, just months into his term, he gave a well-known speech in Prague that summarized a major nuclear security agenda, extremely unusual for a United States president or any national leader. That led to the Iran events in 2015 that were referred to. And then in June 2013, the beginning of his second term, he issued his climate action plan, which then, of course, led up eventually to, I would say, success in the Paris meetings late in 2015. So with that little kind of background about DOE and where I came from in this, all I can say is it was a great time to be leading DOE when the president has two of his highest priorities kind of aligned with our programs. But now today we'll focus clearly on the climate and clean energy transformation that must be at the heart of any successful approach to climate change. And today, it was alluded to a bit already, is an opportune or equally appropriate, inopportune time to discuss these issues. As mentioned, the Intergovernmental Panel on Climate Change, the IPCC, issued a report a few days ago in Asia on the differential impact of 1.5 and 2 degree centigrade global average temperature rise. This came out of the Paris Agreement. We'll talk about it a little bit more, in which the Paris Agreement reinforced the international consensus that we really have to work to keep global warming at no more than 2 degrees centigrade, but with a goal, perhaps aspirational, to come out of this below 2 degrees, preferably at 1.5 degrees. So the IPCC, collection of international scientists, set out to try to look at what would be the differences between 1.5 and 2 degrees, and to try to sharpen those up. We should remember that today we are already roughly 1 degree centigrade warmer than pre-industrial times, so we're well on our way to those two milestones, which we would love to avoid, but we will see that the 1.5 degrees certainly would be very, very, frankly, very hard to see how we're going to manage that. But we'll come back and discuss that. And again, this is enshrined, as I said, in the Paris Agreement. Now, to give a reference frame, and these numbers are, I'm rounding off, but if we continue kind of business as usual, we're probably talking about a 4 degree centigrade increase in this century. If the world executes Paris, and in round numbers, maybe we're talking 3 degrees. And that means that Paris, we should not disparage it. I mean, Paris was an important first step, and I emphasize the first step, because that means that in Paris, most countries adopted goals that one way or another translate to roughly 25 to 30% reductions in carbon emissions by 2030. And so obviously what the numbers I just stated earlier mean is that, okay, if not before 2030, certainly after 2030, we have a lot more work to do, and we have to accelerate the mitigation of greenhouse gas emissions to have any chance to come out in what is viewed as a at least reasonable area. You all know, of course, and we'll come back to this, that already where we are today, it's undeniable Well, apparently not. That's demonstrably untrue. It should be undeniable that we are already seeing significant impacts. Actually, if I could have just the slide come up, I'm just going to show, if they can come up, 2 slides. Yeah, okay. So this is a model of Shanghai just doing nothing but looking at the sea level rise from 2 degrees. I'm not doing half degrees here. From a 2-degree rise in temperature, and then this is the 4-degree rise, which is the business as usual kind of trajectory. Now, this is Shanghai, and obviously that's not. It's not Venice. It's Shanghai, and obviously that would be pretty catastrophic. But of course, we also have to remember that in Shanghai, they have money, and they would take various steps, expensive steps, to avoid this kind of outcome. But the thing we have to remember is there are a lot of other places in the world that don't quite have such nice skyscrapers, that cannot afford the kinds of adaptation that would be required, and we could go on a long roll on that in terms of dislocations it would cause, security challenges, but today we'll just really stay focused on the clean energy solutions to this kind of outcome. Now, in the IPCC report, a very important statement was that to be on the track of the 1.5-degree world would require something like a 45, maybe 50% reduction in CO2 emissions by 2030, not the goals that were set forth by any country in Paris, let alone implementing those goals, I mean actually realizing the goals, and essentially 100% elimination of greenhouse gas emissions by 2050. Later on, I'll come back and interpret that a little bit more, but that's the scale of what is being talked about to reach the 1.5 degree centigrade increase. Personally, I think obviously I very much hope that can be done, but I think in reality, I think 2 degrees is going to be tough, but maybe we can get there. But what's important is that we work really hard to stay as low as we can in that temperature increase to mitigate the dramatic effects. So clearly, if we are to accomplish 1.5 or 2 degrees, we have to go a lot faster in getting carbon out of the system. Now, the second opportune or inopportune fact of this week that colors this discussion is Hurricane Michael hitting Florida with Category 4 force, and then other states. We should emphasize that without getting into too much controversy in the science, it's sort of a no-brainer. Higher sea level, warmer water, warmer air, carrying more water is a great amplifier of the effects of something like a hurricane of this type. And it's the amplification of effects that I will emphasize. Of course, we see other effects that have amplified the impact. For example, in the Houston hurricane, something that is quasi-expected, I would say, in the science is things like the hurricanes getting stationary for a while and just dumping water for a long, long time. But again, the warmer world, the higher sea level and warmer seas, clearly one where we see amplification of these effects. The estimates would be that a change in the surface water temperature of about a half degree centigrade is probably a 10 to 15% hurricane destruction potential amplifier. And so that's, I think, what we have been seeing, unfortunately, in these last years. I might say that I'm on the board of, since earlier this year, of Southern Company, big utility in the Southeast, and the company announced in April that it's already reduced CO2 emissions by 36%, working hard in this way, but of course, this is about the overall warming of the atmosphere, and one of Southern's subsidiaries, Gulf Power, is right in the track of this hurricane, so I'm afraid that we will be learning in a very detailed way about the impact here. Now, I mentioned earlier the word adaptation in the context of that Shanghai picture. I would just note again, so staying with Florida, where we have the hurricane right now, another utility, Florida Power and Light, that one utility, which does not serve all of Florida by any means, that utility has spent $4 billion in hardening assets like poles, preventing or hoping to prevent flooding of substations, putting in a little smart technology to help, especially in recovery, knowing where outages are and the like. If one company has to spend $4 billion, and we will see if that is anywhere near adequate in this hurricane, you can imagine how you scale that up and talk about what the costs will be if we do not mitigate these global warming and climate change by grabbing hold of our energy system and making it more clean. All right, so progress. And let's focus on the United States and acknowledge first that we have made some significant progress. Between 2005, which is an often stated reference year, and 2016, we have had a 14% reduction in carbon emissions, roughly from 6 to 5, a bit more than 5 billion tons of CO2 per year, with about 75 to 80% of that reduction coming from the electricity sector. In terms of carbon intensity, which means carbon emissions per unit of economic activity, GDP, there's been about a 25% reduction in that time. In other words, we have lowered CO2, but we've increased the GDP by even more, which, of course, belies the idea, often stated, that addressing carbon somehow kills the economy. The demand side is critical, managing demand. So, for example, in this time period of significant GDP growth over more than a decade, things like electricity use were basically flat, for example. Again, the amount of energy or electricity used per unit of economic activity has dropped substantially, and that's something we still need to do. To give you an idea as to how so-called demand side or energy efficiency activities can have a big impact, in the Department of Energy is responsible for issuing efficiency standards for appliances and various equipment, electric motors and the like. We accelerated the pace of putting out these efficiency standards, put out over 50 of them. You might not think that standby power of microwave ovens is a big deal, but when you start adding them all up, the projection is that the standards issued in the Department of Energy during the Obama administration will cumulatively, by 2030, result in an avoidance of 3 billion tons of CO2 and consumer electric bill savings of over $500 billion. So this stuff really adds up. A lot of it is not, headline stuff individually, but when you add them up and you keep pushing on this front of energy efficiency, there are enormous gains to be had. But clearly, we also need to accelerate in terms of clean energy generation of electricity or other forms of energy if we are to come anywhere close to the IPCC targets. So the place to start, and I already said that our success over a decade has largely been in the electricity sector, and the electricity decarbonization is in fact the place to start. And in the last decade, we have seen tremendous drops in costs. We have some colleagues here from the National Renewable Laboratory, and they've played a role, as have other laboratories, in things like solar costs dropping by about 70% since 2005. Onshore wind, 60%. Batteries, I'll say 60%, George may argue. Lots and lots of these cost reductions, been very, very critical. That plus state policies is what has led to tremendous growth in renewables deployment. Still not huge, but approaching 10% of our kilowatt hours from renewables. But a big part of it has also been the switch from coal to natural gas, largely because of market dynamics. That is, natural gas, the fracking revolution, and fracking is to many a bad word, but the fracking revolution has been responsible for a majority of our decreased carbon emissions because it has displaced coal. Coal has gone in the United States from roughly 50% to now roughly 30% in the electricity mix, with no indication of an end to the closure of coal plants, to be replaced by a combination of natural gas and renewables. And I might add that natural gas share of electricity production, now it is the biggest source of electricity. It passed coal a couple of years ago, at the same time supplying a tremendous amount of heating, for example, for buildings, and a tremendous amount of industrial energy. So I think one has to recognize that while there are some environmental challenges in the footprint of natural gas production to be addressed, it has been an enormous environmental and overall climate for sure, climate and economic boom. So one question is, will this continue? Of course, we know that in June of 2017, President Trump announced the beginning of the process to leave the Paris Agreement. I might add that we are roughly at the 1,000th anniversary of King Canute, who ordered the waves off the beach. What is sometimes not known is King Canute did that as a humble person to demonstrate to his court that he could not control nature. Such humility seems to have been absent more recently. Perhaps someone really thought he could roll back the waves. But the good news is, within days of that announcement, mayors across the country and many, many governors and well over 1,000 business leaders said, thank you, we're carrying on. We are going to a low-carbon economy. There will be issues, there will be bumps in the road in terms of pace and scale, but I believe it is absolutely clear that we are going to a low-carbon energy economy because the mayors and the governors and the business leaders, the latter in particular, who have to make capital decisions, business model decisions, decadal timescales, not a few year timescales. We saw that here in California Once again, California is always a leader. I think Massachusetts and New York are as well. It would be churlish to mention that Massachusetts comes out #1 in energy efficiency and has for many years, so I won't. For example, just a few weeks ago in California, when Governor Brown hosted the climate summit, and just a few days before that, signed into law SB 100. That was the legislation in California that increased the renewable portfolio standard in 2030 from 50 to 60%. Little detail, you're probably going to hit 50% in 2021 anyway, so let's jack it up. That's a good idea. But maybe even more significantly, with California, obviously a giant economy, we all know, 5th largest economy in the world if it were independent, and noting this economy saying that in 2045, the renewable portfolio standard will be a clean energy standard, meaning that it will not be technology specific, which I highly endorse, just get the job done, no carbon emissions. Now, I'm sorry, out of the electricity sector, we're still talking electricity. That's a big statement. Now, I do think this has to be interpreted carefully, specifically, and Andy Karsner from the Emerson Collective and I wrote an op-ed on this before the legislation was passed, that this should not be interpreted that every single plant must be zero emissions, as opposed to the system being net zero emissions, allowing for some negative carbon technologies, some offsets, and the like. But that's a small argument in the bigger picture right now of a state like California committing to zero emissions electricity. Now, I made that other interpretation because I do think that there will be issues, certainly if one has only variable renewables, wind and solar, and batteries with fairly short-term storage. We will need other ways of meeting long-term storage needs, and I would just say that natural gas, I believe, is still going to be a part of the system, predominantly renewables, but with some natural gas in there, and I'll come back to how that can still be part of a net zero system. I mentioned coal to natural gas as having been absolutely critical to our national progress on lowering CO2, but I do want to emphasize, and this becomes part of that net zero discussion, that sometime down the road, maybe it's 20 years from now, when coal to natural gas switching is no longer part of the picture, natural gas will itself be too carbon intensive for reaching deep decarbonization unless there are other steps taken, and that's why we say that natural gas is certainly a bridge to that low carbon future, but probably will have some role in that deeply decarbonized future as well. Now, staying with electricity, in my view, and it may not be for California, but the point is that very low carbon solutions, I believe, will look very different in different parts of our country and will look very different in different countries in the world, which is why at the Department of Energy, we always emphasized a so-called all of the above strategy, meaning advance the technologies for every and any fuel that can be part of a low carbon future. I personally believe, and I believe this will be true in California as well, that solar and wind are relatively low energy density, relatively few megawatts per square whatever, meter or per acre or whatever. And I think that certainly higher energy density sources will be needed. And that's where, in different parts of the country and the world, I think nuclear technologies will also play a role in a deeply decarbonized future. In particular, I think with fission, nuclear fission, which is what, of course, we have today, I believe that the technology direction of interest is much smaller, passively safe plants, so-called small modular reactors, which have very nice technology features, but also have very much preferable financing features compared to these large 1,000-megawatt plus plants. I mentioned I'm on the board of Southern Company, which is also building the only 2 nuclear power plants in the country right now, and everyone knows their cost has gone almost a factor of 2 beyond what was expected. So I believe the small modular reactors, which can be built on a manufacturing line, will be the future of that technology. But I also want to note that nuclear fusion is getting, believe it or not, is getting a new look. There is, in the nuclear business today, fission and fusion, the most incredible burst of innovation and entrepreneurial activity that field has ever seen, frankly, because they didn't see that much before. But now there's roughly 50 companies, private companies typically, working on various technologies. One of them on fusion, just down the road here, a UCal Irvine spin-out, where I was spending time this morning. It used to be called Tri-Alpha Energy, now it's called TAE. The CEO would be horrified if I invited you all to go visit it, but it really is interesting. New ideas, new technology, a fusion technology that doesn't create even any neutrons, for example, which has enormous implications for providing no radioactivity, et cetera. So look, we'll see. They also work with Google on artificial intelligence for running the experiments. They've also had a technology spin-out called TAE Life Sciences for using the technology for cancer therapy. So it's a new world of entrepreneurial activity in this arena. And I might mention another spin-out from MIT, it's called Commonwealth Systems, is now another approach to fusion, small, compact, which will rely upon being able to build a whole new generation of very high field strength magnets. So anyway, so I think we have a lot of progress has been made, but I do think we still need to keep innovating with these other kinds of technologies. They all, however, are going to require some innovative policy, in my view, because all of these technologies eventually run into the billion-dollar challenge of commercial demonstration, and that's where we're going to need public-private partnerships to advance this. All right, let me talk about, before moving on to other sectors besides electricity, let me talk a little bit about another aspect of the meeting in Paris. We've already mentioned the Paris Agreement, which by definition was the last day of the Paris meeting, COP21 meeting. But on the first day of the Paris meeting, another important event occurred, not as broadly recognized. And that was when national leaders, including President Obama, President Xi of China, and 18 others, announced something called Mission Innovation, with a capital M and a capital I. And what this was a set of goals that each would pursue to double R&D investments in clean energy over a 5-year period. So the idea was we need to accelerate the technology transformation. Innovation is at the heart of climate solutions. And so we, these 20 countries at that time, made that commitment for opening up the innovation pipeline. Now, unfortunately, the current administration got the factor of 2 confused in terms of numerator and denominator in their proposal to Congress. But the good news is Congress didn't listen. And Congress, for the fiscal year 2018 budget, actually increased the clean energy budgets by over 10%. Not quite 20, but I'll take it. And this year as well, for 2019, also an increase, not quite as large, given the budget constraints. But the good news is that when all is said and done, Congress recognizes the importance of these clean energy investments. The climate word is not often used, but the innovation word is very popular. And so I think this has really showed leadership, frankly, in a bipartisan way from the Congress. And while, you know, countries may not meet the factor of 2 in 5 years, but the trends are really very, very positive in many ways. And we are seeing activities together. For example, when Mission Innovation was established, Mexico, one of the 20 countries, asked to take the lead in organizing activities on advanced materials for energy technologies. They held that workshop. The United States and Canada helped with them, a different kind of NAFTA, or whatever it's called now. And that happened, and in fact, the issue of using high throughput experimental methods and very, very large-scale computation and machine learning is in fact moving forward as part of this international collaboration. So there are some good signs. But also in Paris, after the 20 leaders made their point, Bill Gates got up on the stage representing deep-pocketed investors from several continents, committing not to be part of the government activity, but to, in parallel, ramp up the amount of funds available for breakthrough technologies. And they have, in fact, established the Breakthrough Energy Fund and have made a bunch of investments. So this kind of public-private intersection, I think, is a key to be able to accelerate the development and the deployment of these technologies. Now, that's all great, but let me point out, so far in talking about our progress and our technologies, we've talked about electricity. Electricity is, in fact, the lead horse for decarbonization. However, it's less, in the United States, it is less than 30% of our emissions. We cannot deeply decarbonize only by addressing the electricity sector. In my view, we can't deeply decarbonize even if we electrify as much of the remaining sectors as we can sensibly. So we've got to look at our biggest emitting sector now in the United States is transportation, slightly more than electricity. Industry is a large emitting sector. And heating of buildings, commercial and residential buildings, is also a significant part of the emission profile. So we have to address all of these sectors. And frankly, I would say, roughly speaking, they are all harder to decarbonize than electricity. So I think that, frankly, we made some progress, like automobile efficiency standards have helped a little bit, but the needle hasn't moved a whole lot. In the United States, we use more energy for heating than cooling. Warmer weather, less heating, a bit more cooling. It has not led to a major change there. Although we should, I'll make as an aside, I should remind you that cooling in the world is going to be an enormous energy load going forward in the more tropical areas. And in fact, Fortunately, in 2015, we also reached an agreement in Kigali to modify the Montreal Protocol to phase out hydrofluorocarbons from air conditioners over, unfortunately, a rather extended period. But that alone, if successful, and there's still some technology that needs to be developed, successful, that alone could account for about a 0.5 degree centigrade warming by 2100. Anyway, the point is we really need to look at all of these other sectors: transportation, industry, buildings. Buildings don't sound necessarily so difficult, except for the fact that they last an awfully long time. New buildings, no problem, but the old building style. So we are going to need, in my view, to dramatically reshape the R&D portfolio, preferably by expanding it, as we said earlier, with everything like advanced batteries, potentially a hydrogen economy, things like renewable gas. It may not be the most expansive resource, but renewable gas, biogas, large-scale carbon management, and low-carbon liquid fuels. These are examples of the kinds of technologies where we have not really, in my view, invested sufficient effort. A lot of these have very fundamental science problems yet to be addressed. Let me just make a few comments on two of them: the hydrogen economy because I'm getting late, the hydrogen economy and large-scale carbon management. So one of the big challenges, for example, is not just low-carbon electricity, but low-carbon heat. For example, in industry, where high-temperature heat is required. So hydrogen could be a complement to electricity in satisfying a whole bunch of needs in industry and in transportation. It could, in a certain sense, be, in many ways, the replacement for natural gas if we can make an adequate supply at very, very low, with very, very low carbon emissions. Today, hydrogen use is growing, mainly in our refineries, and it is produced by putting natural gas with steam to make the hydrogen, but it releases carbon dioxide. However, one approach can be to start capturing that carbon dioxide. And one plant in Texas, DOE gave some money for. It's been operating now for several years. It does just that. It converts gas to hydrogen for a refinery, captures the CO2, sends it to an old oil well in Texas, and produces additional oil while the CO2 is kept underground. So that's the kind of solution that can help. Of course, and be almost carbon-free. Now, of course, the dream is to lower the costs for electrolysis, to convert water to hydrogen and oxygen without any carbon at all. To do this, we will need capital cost reductions and a lot of cheap carbon-free electricity to run this. But these are possibilities which could really begin to address large parts of the non-electricity sector. Similarly, for transport, fuel cell vehicles are coming along, and I think especially for heavier vehicles could really have a major role. We are, of course, seeing a lot of progress on battery vehicles, and indeed, I think that within a decade, we will have reached the tipping point where the cost of ownership of a 300-mile range electric vehicle will be completely competitive with an internal combustion engine. Let me just skip to large-scale carbon management, which I also believe is essential. What I mean by that is that I think we need to either capture a lot of the carbon emitted from our various facilities or from the air. We need to be able, hopefully, to utilize a lot of that carbon dioxide. I mentioned enhanced oil recovery, but also in large commodities like fuels, maybe cement and the like, and or sequester the CO2 underground, either geologically or biologically through land use or engineered plants. So given the time, I'm just going to say that, that we have some low-hanging fruit right now if we would just incentivize the capture of CO2, and that is industrial plants in which the costs are already fairly low. And Congress recognized this in passing some new tax credits this year. We will need some significant new science to be able to make at scale commodity products using CO2. The holy grail certainly being to convert CO2 plus water and sunlight to a fuel. And there are people here in the audience who have worked on this area. And as I said, geological sequestration is attractive, and we know it can be done at scale, but we should not underestimate the issues of public acceptance, for example. So if we said we wanted to capture and put underground 10 billion tons of carbon per year somewhere down the road, that would require capturing the carbon from about 3,000 coal plants. And each of those coal plants would create over a 50-year lifetime a CO2 reservoir of billions of barrels. This is not for the faint of heart. And so, so scientifically, technically, we know a lot about what we need to do. But again, there are issues. And biologically, we could have engineered solutions such as modifying plants to have much, much deeper root systems, for example, and fix a lot more CO2 underground. So lots of possibilities, and I think many of these possibilities, again, will come together in different ways in different places. So finally, let me just say a word about policy, because I believe the innovation agenda is not just technology. I think technology is key, and the cost reduction that comes with technology advances, but we'll also need business model and policy innovation. On policy innovation, everybody knows the simplest way in principle is to price carbon emissions. That's what you don't want, you put a price on it. But the price has to be at least of the scale of what is called the social cost of carbon. Specifically, one proposal that I think is one of the more interesting ones out there is by a set of Republicans. George Shultz, Jim Baker, Hank Paulson, and others. And what they have said is, okay, let's start with a carbon price of $40 to $50 a ton. That gets attention. It's not the usual $10 or $15, which frankly does not change much in terms of technology choice. So $40 to $50, you start. Then they argue, you collect that, $40 to $50 times 5 billion tons is some serious money. They say the last thing we want is to have the politicals get their hands on this money. So just divide it up in equal amounts as a dividend to everybody. Send it back. That is a progressive tax. It's revenue neutral, and it's progressive. The models suggest the lower 70% of the income distribution will come out ahead. But then, and that appeals to one side of the political spectrum. Then we have the other side, which is, and then you eliminate all other energy subsidies and some class of energy regulations. That appeals to a different part of the political spectrum. And that's what it takes, I think, a balanced approach, something like this, with one other feature which I don't know how to do, and that is to put a carbon charge on imports from countries that are not having a similar carbon policy to avoid leakage of industry out of the country. Maybe blockchain is the answer. Follow the entire supply chain and label the carbon. But that's the kind of thinking that I think we need. And with that, if we had something like that, the technology innovation would just take another big jump, and all kinds of creative ideas would come out for new technologies and new services to supply to people and meet our carbon goals. So, just in summary, I'll just say some of the points I hope you come away with are that obviously we need to be very aggressive on mitigation, but we also need to invest in adaptation. I believe natural gas will be critical in the transition to very low carbon and likely a long-term contributor, maybe with carbon capture and sequestration. We absolutely need an ambitious innovation agenda. It's not only a question of deploying what we have today. That won't get us to the deep decarbonization. Fourth, we need much more focus on these sectors that are hard to decarbonize. Don't take our eye off the ball on electricity, but we got to move and start making real progress in those other sectors like industry and transportation. We will need, I believe, large-scale carbon management of the type I mentioned, and we will need much stronger national carbon policies, such as the tax and dividend, to bring all of this together. Thank you for your attention. I'm sorry I went on so long.